Okay, what we're going to do with this problem is determine what the derivative of this would look like. And if you'll notice that on this particular problem we have a numerator and a denominator, so we could use the quotient rule, and we're going to do this with implicit differentiation, and we know that because of the y squared part that we see there. Okay, so with the u and the v, u will be red, v will be green. We're going to use the quotient rule, and don't forget that it's the low times the derivative of the high minus the high times the derivative of the low over low. Okay, so that's going to be our setup for the quotient rule. Now we need to recognize what u and u prime look like, which would be the high part, and that's not too bad. X minus 1 becomes 1. The same thing with the bottom, which is the low part. So we've got x plus 1, which also the derivative of that becomes 1. So this is our setup that we're going to use, and we're just going to go with the old quotient rule here. Low d high minus high d low over low. Okay? And let's go ahead and set that up. We're going to take the first derivative now. It's going to be 2y. And when you take the derivative of that 2y, because it's implicit differentiation, you have to multiply by dy dx. And the reason we have to multiply by dy dx is because we're using the chain rule. Okay? And so it's no different than how we originally started things off. Okay? We have to use the chain rule to find the derivative of y, which is going to be the dy dx. Then we just write down our low d high minus high d low over low. Okay, and that's going to be the green x plus 1 times the red 1 minus the red x minus 1 times the green 1. And here's the deal. Always put whatever you're subtracting in the quotient rule in parentheses. The reason we do that is so that everything works out well. Okay, that way that'll help you remember to carry through your minus sign to everything in there. All right. Then we simplify a little bit more here and try and combine the like terms. And you'll notice that, after I've got the x plus 1, that's after multiplying by 1, minus x minus 1, that's also after multiplying by the 1, the negative sign gets distributed, and it becomes negative x plus 1 right there in red. Okay? Go ahead and simplify a little bit more. The x's cancel out, and you've got a 1 plus 1, which is 2. And that's going to be 2 over x plus 1 squared. You don't need to FOIL out the denominator. There's no need to do that at all. And the very last step is we're going to get the dy dx all by itself by dividing both sides by 2y, because the derivative is dy dx equals. And so when we go with dy dx equals, we get 2 over 2y times x plus 1 squared. And you'll take one more tiny little step by dividing out the 2's, which leaves us with 1 over y times x plus 1 squared. And that is the derivative of the function that we started with.